All right, aloha everyone. My name is Logan Hicks. Welcome to State of Hawaii's Department of Transportation's 2021 Protect Our Water virtual conference. Coming at you live. I am your moderator for this morning's session titled the BMP Scorecard, a look at BMP deficiencies found on HDOT projects in 2021. Please use the Q&A section, little button down there at the bottom during the presentation to ask any questions you may have. At the end of your presentation, the speaker will have a few minutes to answer any questions. But without further ado, I'd like to introduce the speaker we have for us today. Claudia Akroyd is a construction inspector with Bowers and Kubota. Claudia is the Department of Transportation's Highways Division Inspector, Independent Inspector for the contract construction projects and has worked in the stormwater program for the DOT highways for over 13 years. She will be discussing some of the more frequent BMP deficiencies cited in 2021 and on HDOT construction projects during the third-party inspections that she has conducted and how to make them right. Please help me in welcoming Claudia Akroyd. Good morning, Claudia.
Morning. Thanks, Logan. We'll just scroll through these first couple. Before I get started on the actual presentation, I want to point out to everybody that the new Construction Best Management Practices Field Manual, this is a revision of the old manual, is out and it has been in effect since October 1st for all projects, regardless of when they began. It's available for download at stormwaterhawaii.com. Go to resources, contractors, and look for the one October 2021. It's also available during this conference in the resource section that you can download also for the swag bag. What I'm going to look at is some of the top BMP deficiencies cited in 2021. This is not all of 2021. This is only since through the end of July. I'm going to talk about some of the most common reasons why they were cited as deficient, and in some cases, the fixes. Here's a graphic representation of that. And remember, this is only 7 months. Another form. Now, when you look at the numbers on the right, it's not just 62 storm drain inlet protection deficiencies. Each one of these deficiencies might be several elements. So the number is actually much higher than this. For instance, if there were 4 catch basin problems on a project, it will only show as 1 deficiency. I'm not going to have time to cover them all, but this is what I'm going to cover during this morning's presentation. And what the source of the count has been my third-party reports. And some of these are only very minor and only take about 5 minutes to fix. Some pre-inspection tips. Everybody knows when I'm coming. So the best thing to do is walk the site. Best time to do that is the day before. Fix the stuff that you see as wrong. Fix all the simple stuff. Bigger stuff, have a crew start to repair. If it's not finished by the time the inspection comes, if they're still working on it, bring the inspector back to see that it's finished. Lay on a standby crew, or at least someone to call in a standby crew to repair some of the simple stuff. Then circle back with the inspector. Good intentions go a long way with any inspector. Remember, if you're going to qualify for quarterly inspection, you must have less than 6 minor deficiencies in a 3-month period. In any 1 month, you cannot have more than 2. No major, no critical. If you think about it, a biosock that's damaged, a snake bag at a curb at a catch basin is damaged. Silt fence is pulled away from one of the ties. You've just had 3 minor deficiencies, each of which could probably be fixed in 5 minutes, and you're not eligible for quarterly inspection. Talking about storm drain inlet protection. A lot of these fall in a couple categories: missing or not reinstalled after a storm event, falling in, damaged, properly installed. And I got to talk about some proper installation or suggested fixes. Here's an example of something that would take less than 5 minutes to fix. This culvert inlet is required to be protected by either a Biosock or gravel bag. It keeps getting stolen. If someone had walked the site before I got there, noticed it was missing, put it back in, they would have saved them a deficiency. A lot of times when a heavy storm is coming in, the word goes out to pull inlet protection, because you can end up with flooding in certain areas, which is a safety hazard. The problem comes is that it's not reinstalled right after the storm has passed, and then it becomes a deficiency. We're also going to talk later about how you need to provide protection upslope of that drain. Here's some that are falling into the inlet or into the drain. You've got your dandy curve falling in. This one's backwards. Both these would have taken 5 minutes either to pull out or flip over. Biosock falling in. These may take longer than 5 minutes to fix, and we'll talk a little bit about that in a minute. Damaged. You have snake bags that, if they're filled to capacity, they will pop like a balloon when a truck goes over it. Also, they are shoved off the end of the curb inlet dam. Gravel bags bust open. Biosocks damaged here and here. Each one of these is a deficiency. Dandy curve damaged. Here's some improperly installed. You got a curb inlet dam here that's too short, and we'll talk about the proper installation in a moment. This one has no rock. Those dandy curves will curl up like a pretzel without rock. Insufficient rock. The rock needs to be distributed throughout the flap. Improper bracing. They use a signpost here. Notice it has holes in it. The flow comes from the top to the bottom, which means it runs behind the snake bags and into the drain through the holes. This one has insufficient gravel bags, and it's being overcome with vegetation. For gravel bags, whether they are the big bag or the snake bags, these things will pop like a balloon when they're filled to capacity. The specification for the green snake bags is you only fill with 75%. This allows the gravel to shift, so it may not pop unless it's run over by a bus. If you're using the actual bags, choose a sturdy bag. It may cost more, but it might last a little bit longer. And again, don't fill it to capacity. Have spares on site to switch out prior to inspection. Dandy curves. The specs say fill with 50% clean rock. This dandy curve actually has 50% gravel. The problem is the rock shifts. So I recommend you put about 75% and check often to redistribute the rock. Curb inlet guard. You have to use gravel bags, not sandbags. Again, don't fill them to capacity because they will pop when they're run over. Bag at each end and over each overlap. Here's the curb inlet guard. I showed you this picture where it's too short. If you look at the picture of a curb inlet dam, it looks like it just spans the length of the catch basin opening. In actuality, it needs to be bent back and wedged into the drain. We have a lot of problem with great GDIs. The frame only wedges against the wall on two sides on many. On these sides, there's nothing to hold the fabric against the wall of the box. A simple solution is put in a hunk of wood and wedge it against the rock. Also, please tell your guys not to trim it very neatly just around the drain. You need about 6 inches to allow some flex going in. Here's an alternative to fabric under the grate. It's called an ultra drain guard. It's also a witch's hat, sediment bag, what have you. These things will take the water in an active flow. This is actually taken during heavy rain. Notice the water is going in and not running over the top. The bag has some outlets at the top of the bag. It will also collect some of the sediment. Yes, they're tough to clean out, but they work well. So you don't have to pull them during heavy rain. Biosocks are used a lot for inlet protection, but these things are light and they will float and move during the first rain. And as a result, they're pushed into the drain. If you go get the commercial clips to hold them in place, they won't fall in. Don't use boards or signposts. This allows the water to run behind it. Now, big warning. We tell you to pull inlet drain protection during heavy storms. You must still protect sediment from going into the drains regardless of the direction to pull them. Perimeter control is required to be sufficient to prevent sediment from reaching the drains. Inlet protection is the last resort. It cannot be the only resort. Talking about perimeter control, there's some common easy to fix stuff. We're going to talk a little bit about Biosock versus silt fence. What happens when there's insufficient perimeter control. And we're going to merge that in with some perimeter control versus stockpile protection, staging area perimeter, and going to talk a little bit about buffer zones. Okay, this one up here, easy to fix. This is lapped backwards, and I'll show you a little bit more on that and why. Simply being that could have been easily fixed. Storms will tend to scour out the dirt over the anchorage of a silt fence. Easy to fix. Put more dirt in, tamp it down. Biosock gaps in the protection. I often recommend you put out an extra Biosock because these will shift during the project. So you can shift them so they do overlap 6 inches. You got the all encompassing damaged Biosocks. Here, the silt fence is collapsing because the tie was broken. With Biosocks, there is a directionality to the overlap. You need to consider which way the flow is going. You see the blue arrows with the flow. This means the water comes down, it goes through the overlap, and you end up with sediment on the road. If you think about having the upslope Biosock inside the downslope Biosock, kicking the water back into the project site, you're probably going to get it right. Zip ties can definitely be your friend. Walking a project, you know, I've had project personnel walk around with a pocket load of zip ties. They see a damaged Biosock. They might cut it off or try to zip it up with the zip ties. This could have been easily fixed by pulling it back up and connecting it with a zip tie. Biosock versus silt fence. Biosocks really are not very good perimeter control. When they're dry, they're light. They will float during the initial rain until they become saturated, and they're easily moved. This is what happens during a hard rain and you have Biosocks that are not staked down. They will move and the soil will go under the Biosock. Silt fence may collapse, but it's going to hold a lot more soil and it'll take a lot more effort to collapse it. Notice all the erosion up above it and very little underneath. There is some where it has collapsed, but for the most part, there's no erosion. This is what happens when you have insufficient perimeter control above an inlet. This is not actually a perimeter, it is a swell on a project. They have hydromulch the sides. Hydromulch does have some properties to control sediment runoff and erosion, but not much. If they had been directed to pull this inlet protection, this is on the inside of a project, not on the road, they would have had to file a discharge report, or if it was during an inspection, it would have been a critical deficiency. There is no leeway about the sediment going into the drain. It will not go in, period. So you have to provide sufficient perimeter control upslope so that the inlet is protected. Stockpile perimeter and staging area perimeter are two different things. They are never the same thing. On the left, you see where they used this, they assumed was the perimeter control for the project, but in actuality, it should have just been the stockpile protection. Because you see there's dirt here. This is on top of slope. This was the solution. Perimeter control is never a rack for construction material. This damages the perimeter control and reduces the efficiency. Going to talk a little bit about buffer zones because we seem to be getting a few projects lately that have buffer zones. According to 1155 Appendix C, you must provide a natural buffer zone of 50 feet and sediment control, my underlining, when state water is located within 50 feet of the project's earth disturbance. When you can't provide that 50-foot natural buffer zone, you have to provide a second layer of sediment protection 5 feet from the first. In the SWIP documents, there are exceptions listed, and one of them is for linear projects such as roads. This is not an automatic exemption. Some linear projects will require buffer zones. The buffer zone in the state water level, this is the definition of shoreline. It's the upper reaches of the wash of the waves at high tide, and also the highest wash of the waves that occur. In other words, this includes king tide is where you start measuring your 50 feet. Here's an example of a project that requires buffer zone. This is Leeward Bike Path. It happens to run past a marsh and a state wildlife sanctuary. Here you see an example of where there is a natural 50-foot buffer to the water back here. Notice the sediment protection that they put in. This is an area where they do not have the 50-foot. And you can see here when the marsh was full and they started putting in, you need a second layer. This is, they put in the second layer, and notice the marsh has receded, but you still measure from the high water mark up here. Drip protection. If it uses gas, it has hydraulic fluid, it needs drip protection. You need to put it under all idle and stationary equipment such as cranes. Cranes a lot of times will sit in an area, you may have brought them in that morning, that doesn't mean they are used during the day, but they are stationary, so you need the drip protection. It can either be a drip pad or pan, depending on your SWIP. A drip pad has to have a barrier layer, not the road, a barrier layer, such as plastic and an absorbent layer of the plastic. The plastic needs to be one continuous sheet. If you have overlaps and you have a leak, it will run between the overlaps. You need a berm on the downslope side. And on paving equipment, it must be under the hopper and the roller assembly. These are some of the common problems. Talk a little bit about the evolution of drip pad. This is a project down in near Ala Moana where they were working next to an open water area, and they would bring the crane in. It took them less than 15 minutes to install the drip pad. In actuality, between the second photo where they're installing the plastic in the berm and when they're installing the fabric is 2 minutes. Sometimes drip pads are required and you cannot use pads. For example, under these small remote control excavators, drip pads don't work. This one sprung a leak and you have a bucket. There's a lot of stuff wrong with this picture. Open bucket with hydraulic or oil. You've got no fabric for the drip pad and a filtrate silk sock does not stake down. This shows you very graphically what happens when you don't put a drip pad under paving equipment. Oil accumulates in the hoppers. What you end up with after a rain event is an oil slick out the back of the paver. You should take the plastic past the edge of the fabric. This fabric that we're using has very little absorbency. It only absorbs small leaks. If there's no plastic under it, all it's going to do is filter the oil or hydraulic fluid. This is not a drip pad. What you have is steel plate, nothing absorbent there, and you have the leak running off the steel plate. You can have mobile or fixed drip pads. The one on the left, what they've done is cut a sheet of plastic, put some absorbent material over top of it, stapled it to some 2x4s so that they create kind of a scroll. That can be rolled up, placed on the equipment to move to the next location. Very simple. Cut it to any size, any shape. If you have it fixed, you have to have a downslope berm. And I recommend you place it under the plastic. This gives you a pooling effect should you have a major leak. Make sure your pan is big enough to catch whatever the problem is. On the left, it's either wasn't there when the leak started or it's bouncing out. They need more protection under it. Cutting the top off a bucket or the bottom off a bucket doesn't work. You have to be really, really good for anything to hit that. It needs to be size appropriate. I'm going to talk a little bit about stockpile management. It's to reduce air and water pollution. It's not just water pollution, air pollution also. You should cover with 10 mil plastic to provide protection around the entire stock spoil pile. You got to make sure the plastic's not going to get blown off. If the pile is too large to cover, you can use alternative methods like hydromulching with tactifier. And again, perimeter protection is not stock spoil pile protection. Some easy fix problems. Torn cover. The perimeter is not sufficient. As I said, it needs to be covered with plastic. This is covered with fabric. Fabric, the water will go through and defeats the whole purpose of covering the spoil pile. If you're going to weigh down the plastic, don't use the product that you're covering. Kind of defeats the whole purpose of covering that pile. And of course, there's the pile not covered completely. This is to give you an example of most piles are coverable. What you're looking at here is only half of that spoil pile. That thing goes twice as far back into the trees. On the right, obviously too big, so they hydromulched it. We already talked about this, so I'll just go right through that one. Let's talk about cold patch, asphalt, cement, management, stockpile. These are petroleum-based products. The runoff from them is hazardous. You need to prevent contact with bare ground or other spoils. And like anything that's can contaminate the ground, you need to store it on impervious material, cover against contact with rainwater, and provide perimeter control. Obviously, this is contact with the ground. So now the contract has to double handle it, put it on plastic, cover it, and put perimeter control around. This is another example of a cold patch storage. They put it on steel plates. I highly recommend you, if it's small enough to do that, because if you bring a loader in and scoop it up, you're not going to get a scoop of plastic. Never ever put your waste asphalt or cold patch in with your spoil pile. You've just contaminated that spoil pile. You're going to have to separate it and deal with contaminated soil. One of the big problems with paving projects is when they bring that shuttle buggy back in, they have to run the belt to clear it. Stick a hunk of plastic under the belt to catch the waste asphalt, cover it up, put a Biosock around it, and you're done. Rebar management. It needs to prevent contact with rainwater. So you cover it with plastic, or you rack it off the ground and cover it. If you're under the viaduct can serve as your cover, but you still need to rack it off the ground because water will run quite heavily under the viaduct. This is why you rack it off the ground. This rebar was covered, but because it rained, the rain ran under the plastic, and now the rebar is sitting in the water. This also goes true for creosote poles, galvanized steel. They're considered point source pollution. In dealing with rebar, don't forget the scrap. Don't forget the cages. And remember, cover with plastic, not fabric. And if you got steel workers out there, since they're not involved with the BMPs, they're allowed to leave scrap around. Police it up, store it properly. You're required by Section 209 of the DOT specifications to have a construction entrance anytime you traverse across the ground to the asphalt. The excavator on the left has no construction entrance. Paving project, they put their dirt pad right at the edge of the road, so all they had to do was swivel and go out onto the asphalt. You have your traditional rock entrance. This one on the left has good size rock, fabric under it, perimeter protection. On the right, this is a very anemic construction entrance where the rock is too small and it's being overwhelmed and you can see the tracking. It needs to be refreshed. Either easiest thing to do is bring in new rock. There are alternatives. And one is the GEOTERRA grid. This may be more expensive than rock, but the advantage is you can unbolt it and take it to your next project. But keep in mind, it still needs to get cleaned. Track out plates, either used separately or in conjunction. These two need to be cleaned on occasion. And also what I recommend is when you put these in, make it so that the vehicles have to drive over it. If there's an opportunity to drive around it, people will, because they will rattle your teeth. Mud mats. These are not good in heavily mud environments because they become clogged too easily. One disadvantage is that once they're damaged, they're not really repairable. There's also a system that's popped up occasionally around the island called a FOD. I have not seen it used, so I can't tell you anything about it, but it has been used on island. Concrete waste management. Basically, the concern is for the cement. Anything that contains cement, you need to consider putting in a washout. You need to store it so it doesn't come in contact with rainwater. Don't allow it to harden on the ground. It needs to be placed when wet. And if you're doing a trimming pour or in the drill shaft where you're displacing water, as it comes up, you need to collect that as concrete wash water. Here's your standard in-ground washout. However, you need to make sure it's one sheet of plastic and no holes and no overlaps. Any holes or overlap, the water will seep through and contaminate the groundwater. Make sure you have enough to hold your waste. You should only be filling your washouts 75% full, so that if it rains before you get it covered or it dries, you won't have runoff. It doesn't matter whether you're using a commercial washout or you're making your own box. They will leak. The other thing is people miss and dribble around the side of it. If you place secondary protection underneath it, and this is not a requirement, it's just a recommendation, and berm under the plastic, you create a secondary pool, making cleanup much easier. Covering concrete left on the ground doesn't make it right. This should have been cleaned up when it was wet. On the right, they tried. However, not quite big enough so that it washed off the board. Does anybody have any questions?
Yeah, thank you, Claudia, for the presentation. If anybody does have any questions, feel free to type them in the Q&A chat at the bottom. We'll feature down there.
I think, Logan, you can answer that one.
Yes, so we do not actually have any copies of the slides available, but this session is being recorded. So you will be able to view it for 30 days after the presentation. And you can also go to our YouTube channel at stormwaterhawaii.com, and you'll be able to view the presentation there as well.
I think the slides are also posted on the Stormwater Hawaii eventually.
Oh, okay, very good.
The answer to the question is trimming water has to be collected. The answer is yes. As you bring the concrete up, you'll notice the water is can turn gray because of contact with the cement. That means it's contaminated with the cement in the concrete.
And the green socks, you mentioned 75% full. That is for rock filled only. That is for rock filled only.
Yes, if you look at the specifications for the green snake bags, you will find that it says they recommend only 75% full. That doesn't mean if it's a stuffed sock, I will deem it as deficient. It just means you're more likely, if somebody runs over it, it's going to pop like a balloon.
All right. Does a parked water tanker truck need drip protection for dripping water?
Two things. The water tanker truck, the water in that truck is considered construction water. It should, if it's leaking, it should be fixed. So since it is construction water, it cannot be allowed to run into an inlet. If it's leaking, I would recommend you park it someplace where it can be absorbed into the ground.
For drilled shafts, does all the water from the shaft need to be collected and disposed of once the concrete begins pouring?
I won't say all of it because I've been on some chummy pours where you're in the middle of the ocean. So a lot of the initial water is not contaminated. And I've also seen where it's been placed in and everything coming up is gray. My advice is put it in a Baker tank or frac tank or whatever you're using to collect that water, so you can sort out the good water versus the bad.
Right. A person asked, installing a pan versus a drip pad under heavy equipment is a violation.
Project along waterways. Road paving projects along waterways does not lead. I'm not sure about that. I think what we're talking about here is secondary protection for sediment control. Part of it depends on what they're doing in the roadway. If they're constructing a road where there's, from grading on up and you're running next to waterway, that will probably require a buffer zone. But if you're just cold planing 2 inches and putting back, that is not considered disturbed.
For paving, does the water from the rollers need to be contained?
Yeah, if that's dripping out and it's dripping into a drain, yes, it would need to, it cannot go into an inlet because that's considered construction water. Again, that's one of those that if it's absorbed into the ground and it's clean water, that might be okay. That'll have to be looked at on the case by case. And there's one at the top, says installing drip pan versus drip pad under heavy equipment. Is it a violation? The best type of drip protection is a drip pad. Now, depending on what the heavy equipment is, if it's a dump truck and you can use a drip pad. If it's a paving equipment, you must use a drip pad. But it also depends on what's in your SWIP. If your SWIP says you're going to put everything on a drip pad, you put everything on a drip pad.
It says the CCH and DOT workers have to oblige by these BMP practices.
If you're working on a state DOT project, you're required to follow the state BMP manual anywhere on state highways, regardless of who is the contractor. The best thing to do is look at the special notes in your engineering drawings, because some city and county projects will require following the state manual if there is certain types of federal funding.
All right. When cold patch is placed and as it wears out and starts to lift, what is the rule for cleanup? What level of deficiency would that be?
Okay, this, you're talking about fines on the road. When it starts to unravel, like when they put it around the steel plate, and it basically becomes debris that can collect in the gutter area. It might be a deficiency for the gutter area. Needs to be cleaned, minor, depending on the level of unraveling. What Why do soils that will be reused need to be covered and do not need to be covered? And do they need to be covered if there's no inlet in sight? Per state rules, all spoil and stockpiles, if they have fines in them, they do need to be covered against contact with rainwater and from wind erosion. It's not just runoff from stock spoil piles. It's also wind erosion can take those fines and blow them into the waterways. So they must be covered with full perimeter control.
All right. During a dewatering operation, what is the best way to contain or dispose of the large amounts of water that would be generated?
That will depend on your dewatering permit and your plan. In most cases, you can use frac or Baker tanks. Depending on what you're dewatering will depend on what you can or cannot use. You need to look to your permit for that particular operation. So I can't give you a blanket answer on that.
Mm-hmm. Stabilized entrances. Does it need to be replaced, or can extra rock be added when the area becomes filled with dirt?
In terms of replacing, digging the old rock out, no. You can add extra rock. You can, if it's just a top layer, you might be able to scarify the entrance to bring the rock back up. Adding extra rock is probably the easiest.
All right. And do the drain slots at the bottom of portable concrete barriers need BMP protection?
Okay, I think we're talking about K-rails or Jersey barriers here. Those are not BMPs. They do not provide any sediment control. There are gaps in between the Jersey barriers, and there's the pick points underneath. And yes, they would need, if they're situated in such a way that there might be sediment running towards them, there needs to be perimeter protection, not Jersey barriers.
All right. Well, thank you again, Claudia. That will conclude our session for today. Thank you all for attending. The next session begins at 9 a.m. So please return to the sessions tab in the to see the next breakout sessions. If you're experiencing any technical issues, please visit the info desk for assistance. Also, don't forget to stop by and check out our vendors in the middle of the break. Well, thank you very much again, Claudia, and you guys have a great day. All right.